Welcome to another session of chapter Limits and Derivatives. Today we are going to study about derivatives. Derivative of a function means rate of change of function with respect to change of values in its domain. Otherwise, rate of change of dependent variable with respect to independent variable. Now, what is dependent, independent? Consider one equation y equal to x square plus 5. Here we can consider x as independent and y as dependent, because if we give any value for x, there will be corresponding change in y. When x equal to 1, we will get y equal to 6, and x equal to 2, we will get y equal to 9, etc. So, in general, dependent variable can be represented in terms of independent variable in this form. Y equal to f of x, where x is independent and y is dependent. Suppose there is a small change in x, that is delta x. That means x changes to x plus delta x. Then there will be corresponding changes in y also, and y changes to y plus delta y. Therefore, this equation implies y plus delta y changes to y plus delta y equal to f of x changes to x plus delta x. That means delta y is equal to f of x plus delta x minus f of x. Minus y will get y equal to f of x. Therefore, delta y by delta x is equal to f of x plus delta x minus f of x by delta x. This one is rate of change of y with respect to x. There are two types of rate of change. One is average rate of change, and one is instantaneous rate of change. I will explain it by using one diagram. Okay. Now consider graph of the function y equal to f of x. The diagram is x-axis. This one is y-axis. Suppose graph of the function is like this. Okay. So this point is A, and this one is B, and point on x-axis is x. Then coordinate of A will be x, y equal to f of x. Suppose this length is delta x. Then coordinate at this point is x plus delta x. Then corresponding point will be on the graph. Suppose that point is B. Then coordinate of B will be x plus delta x, y equal to f of x plus delta x. Okay. Now you can join these two points, and now we can form a right angle triangle. Now what about BC? BC is change in y, right? Change in y. Earlier it was up to this much. Now it is up to this point. So this point is change in y, that is delta y, and this AC is change in x, that is delta x. So delta y by delta x represent change in y with respect to change in x, that is actually f of x plus delta x, height up to this much minus height up to this much, that is f of x minus f of x by delta x. This actually represents average rate of change, because at this point rate of change of y with respect to x will be greater than this value, and at this point rate of change of y with respect to x will be less than this value, because this point is below this line. So this line represents delta x, which is average rate of change. Okay. Now I will tell what is instantaneous. Consider graph of the function y equal to f of x. So this is our x-axis, and this one is y-axis. Suppose this is graph of the function. Okay. This point is A, that will be B. Suppose point on x-axis is x. Then coordinate of A will be x, f of x. Right. Suppose this length is delta x. Then this point is x plus delta x. Then there will be one corresponding point on the graph. Suppose that point is B. Then coordinate of B will be x plus delta x. And what about y coordinate? It is f of x plus delta x. Okay. Now draw a line parallel to x-axis from A and draw a line perpendicular to x-axis from B. And this length is actually change in y. That is delta y. And this one is change in x. That is delta x. So change in y by change in x is delta y by delta x. That is actually this height minus this height. So y coordinate actually represent height. So what is y coordinate here? That is f of x plus delta x minus f of x. Height up to this mesh is same as this one. That is equal to y coordinate of this coordinate. That is f of x by delta x. This is actually rate of change of y with respect to x in a particular interval. This is the length of that interval. Suppose we want to find rate of change of y with respect to x at this particular point A. At this particular point A. How we can find? For finding rate of change at a particular point A, we have to reduce. Anyway, we need starting point and end point. So this is starting point. We have to make end point very near to this A. For that, you have to reduce length of delta x. If length of delta x tends to 0, we will get rate of change of y with respect to x at this particular point. So limit delta x tends to 0. Delta y by delta x represent rate of change of y with respect to x at this particular point. That is instantaneous rate of change. Means rate of change at a particular point. It is denoted by dy by dx. Therefore, what is the definition of dy by dx? Dy by dx will be equal to limit delta x tends to 0. Delta y by delta x, that is f of x plus delta x minus f of x by delta x. Instead of delta x, we can take h also. Therefore, definition is limit h tends to 0, f of x plus h minus f of x by h. That formula is called first principle formula or first principle method. Using this formula, we can find derivative of all functions. That is instantaneous rate of change. Therefore, dy by dx equal to dy by dx is equal to limit h tends to 0, f of x plus h. Instead of delta x, we can take h minus f of x by h. Okay. Suppose we want to find derivative of function f of x is equal to k. That means you have to find change in function when x changes. If this is a constant, there will not be any change. So let us find. So formula is dy by dx. You can find answer by using first principle formula. So dy by dx is equal to limit h tends 0, f of x plus h minus f of x by h. F of x is given as k. So what about f of x plus h? Since it is a constant, value will be always equal to k. So this is equal to limit h tends to 0, k minus f of x again k by h. That is limit h tends to 0, 0 by h. That is 0. Limit of 0 equal to 0. That means derivative of a constant function is always equal to 0. Okay, because it is a constant. If we take any value for x, function will be always equal to k. There will not be any change. So, derivative of a constant is always equal to 0. This is our first result. Okay. Now consider second function, that is f of x is equal to x raised to n. how we can find derivative? The same formula we can use. If f of x equal to x raised to n, what about f of x plus h? This will be equal to x plus h whole raised to n. Therefore, by first principle formula, we have limit h tends to 0, f of x plus h, that is x plus h whole raised to n, minus f of x, x raised to n by h. This one you can expand by using binomial expansion. So, this will be limit h tends to 0, x raised to n plus nc1 x raised to n minus 1 into h plus nc2 x raised to n minus 2 into h square plus etc. Last term will be h raised to n, right, b raised to n minus this x raised to n whole divided by h. So you can cancel x raised to n. In the remaining all term we can take h as common. So this will be limit h tends 0, h into nc1 x raised to n minus 1. What about second term? nc2 x raised to n minus 2 into h, etc. Last term will be h raised to n minus 1. Okay, whole divided by h. So we can cancel this. Now we have to substitute h equal to 0 in this term. So in first term there is no h term. All the other term containing h. So all the other term will be 0 except first term. So what is your answer? nc1 into x raised to n minus 1. nc1 equal to n. So nx raised to n minus 1. So derivative of x raised to n is nx raised to n minus 1. For example, if you want to find the derivative of d by dx of x raised to 5, you have to compare with this formula, and answer will be n into, means 5 into x raised to n minus 1, that is 4. So now we can find derivative of trigonometry functions. So consider f of x equal to sin x. F of x equal to sin x. We can use first principle formula. So dy by dx is equal to limit h tends to 0, f of x plus h, that means sin x plus h, minus f of x, that is sin x, whole divided by h. Here you can use sin c minus sin d. Limit h tends to 0, sin c minus sin d is 2 cos c plus d by 2, x plus h plus x, that is 2x plus h by 2, into sin c minus d by 2, x plus h minus x is h, okay, h by 2, whole divided by h. This one you can rearrange. So limit h tends to 0, 2 cos x plus h by 2 into sin h by 2 by h. Actually sin limit x to 0, sin x by x is equal to 1. So sin h by 2 by, this will be h by 2. So we can divide by 2 into 2. Now we can apply limit h tends to 0. So this will be equal to 2 into cos x, because h equal to 0, into sin h by 2 by h by 2 equal to 1, into this 1 by 2. So you can cancel 2 and 2. So derivative sin x will get cos x. Okay. So derivative sin x equal to cos x. D by dx of sin x is equal to cos x. Now we can find derivative of cos x. F of x equal to cos x by using first principle formula. So dy by dx equal to limit h tends 0, f of x plus h means cos x plus h minus f of x, that is cos x by h. Cos c minus cos d. What is cos c minus cos d? Minus 2 sin c plus d by 2 into sin c minus d by 2. So this will be limit h tends 0 minus 2 sin c plus d by 2 x plus h plus x, that is 2x plus h by 2 into sin c minus d by 2 x plus h minus x, that is h by 2 whole divided by h. Okay, this is equal to limit h tends to 0 minus 2 sin x plus h by 2. We can divide with 2, and this one we can write as sin h by 2 by h. This one you have to convert to h by 2, so into 1 by 2. Now we can apply limit, so we'll get minus 2 sin x into sin h by 2 by h by 2 1 into 1 by 2, that is minus sin x. So derivative of cos is equal to minus sin x. Okay. Now we can study algebra of differentiation. Suppose f of x and g of x. F of x and g of x are two functions. Then d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. This one you can prove like this. Let h of x is equal to f of x plus g of x. Here you can use first principle formula. Okay, so dy by dx is equal to limit h tends to 0 h of x plus h, right? H of x plus h minus h of x by h. Okay, this one you have to find. This is equal to limit h tends 0. What is x plus h? F of x plus h plus g of x plus h. Okay, minus h of x. H of x equal to f of x plus g of x whole divided by h. This one we can rearrange as limit h tends to 0 f of x plus h minus f of x by h plus limit h tends to 0 g of x plus h minus this g of x whole divided by h. This is definition of first principle. So this is derivative of f of x. So d by dx of f of x, and this one is derivative of g of x. First principle formula, d by dx of g of x. Same way we can find second formula, that is if f of x and g of x are two functions, then d by dx of f of x minus g of x will be d by dx f of x minus d by dx of g of x. Okay. Now product rule of differentiation. Okay. Suppose f of x and g of x are two functions. We want to find derivative of f of x into g of x. So let h of x equal to f of x into g of x. That means you want to find derivative of h of x by using first principle method. So dy by dx and y equal h of x. So derivative is equal to limit h tends 0 h of x plus h, that means f of x plus h into g of x plus h, right, minus h of x, that is f of x into g of x whole divided by h. This one in next step we can write like this: limit h tends 0 f of x plus h into g of x plus h minus g of x plus h into f of x. I am subtracting this term. Same way I have to add g of x plus h into f of x minus this last term, that is minus f of x into g of x whole divided by h. Now from the first two terms you can take g of x plus h as common. So limit h tends 0, g of x plus h into f of x plus h minus f of x by h. Just you can split. Okay, then limit up, we can apply to second term also. Limit h tends 0. Then the last two terms we can take f of x as common. F of x. The remaining terms are g of x plus h minus g of x all divided by h. Now f of x plus h minus f of x by h is f dash x. So this will be, let's apply limit. So g of x into d by dx of f of x. Okay. Plus second term f of x into, what about this one? G of x plus h minus g of x by h is g dash x. D by dx of g of x. That is g dash x. So product rule is g of x into d by dx f of x plus f of x into d by dx of g of x. That is first function into derivative second plus second into derivative first. Okay. First into derivative second plus second into derivative first. Now we can derive division rule. That f of x and g of x are two functions. Then you have to find derivative of f of x by g of x. So let h of x equal to f of x by g of x and let y equal h of x. So we want to find dy by dx. That is limit h tends 0. H of x plus h, that is f of x plus h by g of x plus h minus h of x, that is f of x by g of x whole divided by h. This is equal to limit h tends 0, g of x into f of x plus h minus f of x into g of x plus h by g of x plus h into g of x by h, that means into 1 by h. This is equal to limit h tends 0, g of x into f of x plus h minus g of x into f of x plus, we have to add same term, plus g of x into f of x minus f of x into g of x plus h by g of x plus h into g of x into h. Now from the first two terms you can take g of x as common. So limit h tends 0, g of x into f of x plus h minus f of x by h. This is. Then from these two terms we can take minus f of x as common. Okay. Then remaining terms will be g of x plus h minus g of x whole divided by h into, this term is there, into 1 by g of x plus h into g of x. Okay. Now we can apply this limit. So first term will be g of x, then f of x plus h minus f of x by h, that is f dash x, otherwise d by dx of f of x, then minus f of x into g of x plus h minus g of x by h, that is d by dx of g of x, d by dx of g of x into 1 by, this h becomes 0, g of x and g of x, g square x, that is whole divided by g square x. So this formula is called quotient rule. Okay. G of x into d by dx f of x minus f of x into d by dx of g of x by g square of x. Okay. So we derived four formulas. First one, d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. If this is minus 1, it will be minus. Now second formula, d by dx of f of x into g of x. This formula is called product rule. Okay, it's equal to first function into d by dx of second plus second into d by dx of first. Formula is called product rule. And fourth one is quotient rule. D by dx of f of x by g of x is equal to, first we can write denominator, that is g square of x. Here you have to start with denominator, that is g of x into d by dx of f of x minus, okay, f of x into d by dx of g of x. So we can write one more formula, that is d by dx of k into f of x, where k is a constant. Actually, I have to use product rule. If we use product rule, it will be like this. First into d by dx of f of x plus second into d by dx of first. What about derivative constant? Is equal to 0. So this answer will be always k into d by dx f of x. Okay, k into d by dx of f of x. So d by dx of k into f of x is k into d by dx f of x, constant into derivative function. Okay. Now we can derive some more standard result by using algebra of derivatives. Okay, let us start with tan x. F of x equal to tan x. That means tan x equal to sin x by cos x. Okay, y equal to tan x. We want to find dy by dx. Here you can use quotient rule, division rule. You can take f of x as sin x and g of x as cos x. So by formula, denominator is g square of x. So it will be cos square of x. Okay. Then g of x into means cos x into d by dx of f of x, that is sin x, minus f of x into d by dx of cos x, d by dx of cos x is equal to cos x into derivative sin x, that is cos x. You will get cos square x. Then minus sin x into what is the derivative of cos x? Minus sin x. Minus or minus plus, and sin x into sin x, sin x square x. You will get cos square x plus sin square x by cos square x. That is 1 by cos square x. 1 by cos square x equal to sec square x. Okay. So derivative of tan x equal to sec square x. Okay. Now next standard result, that is cot x. Y equal to cot x. Cot x equal to cos x by sin x. Here also we can use quotient rule. So dy by dx equal to g square x means sin square x. Then g of x into d by dx of cos x, d by dx f of x, that is derivative cos x minus sin x, minus f of x. F of x is cos x into d by dx of g of x, that is sin x. Derivative sin x equal to cos x. So we'll get minus of sin square x plus cos square x. From these two terms, we can take minus outside. So minus of sin square x plus cos square x by sin square x. So it will be minus 1 by sin square x. Minus 1 by sin square x is minus cosec square x. Okay, so derivative cot x is minus cosec square x. Now we can find derivative of sec x. Y equal to sec x. Sec x means 1 by cos x. Here also you can use same quotient rule. So dy by dx is equal to cos square x. Okay, then g of x into means cos x into derivative f of x. Derivative of 1, that is 0, minus f of x into d by dx of cos x, that is minus sin x. So you get sin x by cos square x. This one you can rewrite. So 1 by cos x into sin x by cos x. Okay, that is 1 by cos x is sec x and sin x by cos x is tan x. So derivative sec x equal to sec x into tan x. Next, y equal to cosec x. Cosec x. Cosec x is 1 by sin x. Okay. So dy by dx is equal to sin square x, that is g square x, into sin x into derivative 1, that is 0, minus 1 into derivative sin x is cos x. So this is equal to minus cos x by sin square x, that is minus 1 by sin x into cos x by sin x. Minus 1 by sin x is cosec x. So answer is minus cosec x into cot x. Minus cosec x into cot x. That is the derivative of cosec x. So I explained derivative of all trigonometric functions. Derivative of sin x cos x, derivative of cos x minus sin x, derivative of tan x sec square x, derivative of cot x minus cosec square x, derivative of sec x is sec x into tan x, and derivative of cosec x is minus cosec x into cot x. Now we can do some problems. Okay, first question, find dy by dx where y equal to sec x plus tan x minus x raised to 5. This one is three functions, sum of three functions, f of x equal to sin x, g of x tan x, and we can take h of x equal to x raised to 5. If it is sum of two functions means derivative of first function plus derivative of second function you have to find. So dy by dx equal to derivative sec x plus derivative tan x minus derivative x raised to 5. What about derivative sec x? That is sec x into tan x. Now derivative tan x is sec square x and derivative of minus derivative x raised to 5. You have to use x raised to n formula, that is n into x raised to n minus 4. So this one is the answer. Next question, find dy by dx. Y equal to x plus sec x into x minus tan x. Actually, this one is product of two functions. This one you can take as first function, and this one as second, f of x into g of x. So you can use product rule. Dy by dx, that is product to first function, that is x plus sec x, first into derivative of second, derivative of x minus tan x. Actually this one is difference of two function. So derivative x minus tan x is derivative of x minus derivative of tan x. Derivative x is 1 and derivative of tan x is sec square x. So first into derivative second plus second one is x minus tan x. X minus tan x into derivative of first, that is derivative of x plus sec x. Derivative x plus sec x is 1 plus sec x tan x. Okay. Now next question, y equal to x by sin x. Find derivative. Here I use quotient rule. So dy by dx equal to g of x is sin x. So denominator is g square x. So it will be sin square x. Then g of x into sin x into derivative x, that is 1, minus x into derivative sin x is cos x. Okay. This answer is sin x minus x cos x by sin square x. Sin x minus x cos x by sin square x. That is the derivative of x by sin x. Next one, y equal to 5 into sec x plus 10 into sin x plus x cos x. Okay, we have three functions f of x, g of x and h of x. So derivative of y with respect to x is derivative of first function, that is derivative of 5 into sec x. So 5 into, but 5 is a constant. So constant into derivative of function you have to find. So 5 into, what is derivative of sec x tan x plus, again same form, constant into function. So constant into derivative function, 10 into derivative sin x is cos x plus, here we have to use product rule because both are variables. So first function into, what is derivative cos x minus sin x plus cos x into derivative of x is 1. This is the answer. Consider another question, y equal to x by 1 plus tan x. Here you have to use quotient rule. So dy by dx equal to g of x whole square, that is 1 plus tan x whole square. Then g of x into means 1 plus tan x into derivative of x, that is 1, minus x into derivative of 1 plus tan x. What is derivative of 1 plus tan x? Derivative of 1 equal to 0 and derivative of tan x equal to sec square x. Okay, so answer is 1 plus tan x minus x into sec square x by 1 plus tan x whole square. Okay. Now consider the question, y equal to a by x raised 4 minus b by x raised 5 plus cos x. Here a and b are constants. Okay. This one we can write like this, a into 1 by x raised 4. Okay. Minus b into 1 by x raised 5 plus cos x. Okay. Y. Now we can differentiate. So dy by dx equal to a into derivative of 1 by x raised 4. Derivative of 1 by x raised 4 is minus 4 by x raised to 5. Okay. And minus b into, minus b is a constant, minus b into derivative of 1 by x raised 5, that is minus 5 by x raised to 6 plus derivative of cos x is minus sin x. This is the answer. What is derivative of 1 by x? Derivative of 1 by x is, actually 1 by x is x raised to minus 1 and its derivative is minus 1 x raised to minus 2 and in expression minus 1, that is minus 1 by x square. Derivative of 1 by x is minus 1 by x square. Same way, if you are finding derivative of 1 by x square, 1 by x square we can write as x raised to minus 2 and its derivative is minus 2x raised to minus 3, that is minus 2 by x cube. So derivative of 1 by x is minus 1 by x square, derivative of 1 by x cube is minus 2 by x cube, derivative of 1 by x cube will be minus 3 by x raised 4, derivative of 1 by x raised 4 will be minus 4 by x raised 5, derivative of 1 by x raised 5 is minus 5 by x raised 4. In general, derivative of 1 by x raised to n will be minus n by x raised to n plus 1. This formula you can note down. Okay, we consider another question, y equal to x raised to 5 minus cos x by sin x. You have to find dy by dx. Dy by dx. So numerator you can take as f of x and this one is g of x. Quotient rule you can apply. So g square of x, sin square of x, then sin x into derivative of f of x, derivative of this term. Actually difference of two function. So derivative of first term minus derivative of second term. 5 into x raised 4, that is derivative of first term, minus derivative of cos x is minus sin x. So this will become plus sin x minus f of x, that is x raised to 5 minus cos x into derivative of g of x, that is derivative of sin x cos x. Okay, another question, y equal to ax plus b by px square plus qx plus r, where a, b, p, q, r are constants and variable is x. So dy by dx. Dy by dx equal to g square of x, that is px square plus qx plus r whole square into g of x, px square plus qx plus r into d by dx of f of x, that is derivative of ax plus b. Derivative of ax is a into derivative of x. Okay, derivative of x is 1, so it will be a. Okay, and derivative of b equal to 0. Minus f of x, x plus b into derivative of g of x, means derivative of this term. What about derivative of px square? That is p into derivative x square. P into derivative x square is 2x. 2px we can write. And second one is q into derivative x. Derivative x is 1. So q into 1, q. And derivative r equal to 0. Okay. So this is the answer. Okay. Next question. Find derivative of y equal to x raised to 4 into 5 sin x minus 3 cos x. Here next question. Find derivative of y equal to x raised 4 into 5 sin x minus 3 cos x. Here you have to use product rule. So x raised 4 as first function and this term as second function. So dy by dx is equal to x raised 4 into first function into derivative second, that is 5 into cos x plus 3 sin x, okay, plus second function, that is 5 into sin x minus 3 cos x into derivative of first, that is derivative x raised 4, 4 into x cube. So actually I use product rule. If function is f of x by g of x, quotient rule. If function is f of x and g of x, then product rule. Okay. Next question. Find derivative of y equal to sin 2x. Sin 2x we can write as 2 into sin x into cos x. Okay. Y. So dy by dx. 2 is a constant. So 2 into d by dx of sin x into cos x you have to find. Derivative of sin x into cos x you can find by product rule. So 2 into first function, that is sin x into derivative of cos x minus sin x plus second function cos x. Cos x into, that is derivative of sin x, again cos x. So this is equal to 2 into minus sin square x plus cos square x. Cos square x minus sin square x is cos 2x. So answer is 2 into cos 2x. Answer is 2 into cos 2x. Okay. Next question. If f of x equal to x plus 1 by x, find f dash x. F dash x means derivative function. Okay. If y equal to x plus 1 by x, we want to find dy by dx. That is the meaning. So dy by dx. Derivative of first function, derivative of x equal to 1 plus derivative of second, derivative of 1 by x equal to minus 1 by x square. Okay, derivative of 1 by x equal to minus 1 by x square. Let us consider another question. Y equal to x raised to minus 4 into 3 minus 4 x raised to minus 5. We want to find derivative. We can use product rule. We can take this one as first function, this one as second. So dy by dx is equal to x raised to minus 4 into derivative second term. Derivative of 3 equal to 0. Minus 4 is a constant. Minus 4 into derivative of x raised to minus 5. That is minus 5 x raised to minus 5 minus 1 is minus 6. Plus second function, that is 3 minus 4 x raised to minus 5 into derivative of first, that is minus 4 x raised to minus 4 minus 1 minus 5. So we can simplify x raised to minus 4 into 20 x raised to minus 6. Okay. Plus 3 minus 4 x raised to minus 5 into minus 4 x raised to minus 5. So this is the answer. So in this section we studied how to find derivative of a function by using first principle method, and we derived some formulas like sin x, derivative of sin x, derivative of cos x, tan x, cot x, sec, cosec, derivative of x raised to n, derivative of constant, etc. Actually, there are lots of formulas in this section. All those formulas you will study in +2 classes. So today we can wind up our section. Thank you.